Start capacitors. Sometimes start capacitors are used in residential and commercial refrigeration systems, and these start capacitors are used to provide a larger phase shift for the start winding. And what it does is it increases the starting torque of the compressor and allows the larger compressors to start up without a huge amp draw. The starting capacitors are only in the circuit for a few seconds, and you'll see that most of them will have bleed resistors across the terminals. And you need the bleed resistors to dissipate the capacitor charge and discharge the capacitor basically. And the bleed resistor prevents the relay contacts from arcing on the next startup, because if you didn't have that bleed resistor in there, that capacitor would have a charge on it, and when the relay contacts went to close, the power and the voltage and current stored in that capacitor would be just discharged across the relay contacts, and that causes them to arc and spark, and then it shortens the life of the relay. The one thing to remember is you always replace capacitor with the same microfarad rating and an equal or greater volt amp capacity. We'll take a look at that here in the next few slides. But first, let's look at a start capacitor with a bleed resistor. So here is the start capacitor. The bleed resistor is down here. This is a 1500 ohm bleed resistor. And if you have to check a capacitor, you have to take this bleed resistor out of the circuit. Otherwise, it's going to throw off your capacitance reading when you're checking the capacitor. The dilemma is if you don't have a soldering iron to get that bleed resistor connected back up to the capacitor, that is always a problem. I have never soldered one back in, but you need to find a way to connect it. One of my recommendations, and what I have usually done, is that you can clamp it with a crimp connector onto a female spade connector and then plug it back onto that the capacitor terminals. So back in the day, we had to have a separate capacitor tester, and nowadays we have that built into our multimeter, which is great. So that indicates if the capacitor is good, and it also gives you the actual capacitance. Start capacitors have a microfarad range, so it would say 145 to 160 on there, and the perfect reading is in the middle of the microfarad range of the capacitor, but as long as you're within the range, you're good to go. So here's an example here, checking a capacitor. Here's one that the microfarad range is 145 to 174 microfarads, and we're reading here with an old school capacitance checker 151 microfarads, and that falls pretty much in the center of the range, and this is good. Anything less than 145 or more than 174, you should replace the capacitor. Okay, the volt amp capacity on capacitors, and that is the VAC. It's determined by the motor manufacturer, and it's matched to meet the requirements and specification of the compressor or motor to which it is connected. Now, you will have to replace the capacitors, start capacitors, and the thing to remember is that the volt amp capacity must be the same or greater, and we'll take a look at that here in this next slide. So here are 145 to 174 microfarad capacitors with different volt amp capacities. And if you look at this one, we have 145 to 174 microfarads, and it's 125 VAC. And the other ones are more difficult to read, but they would go up to, for example, 230 VAC, 440 VAC, and so forth. Now, if you need to replace the 125 VAC capacitor, you could do it with any of these three. It's best if you get the right one, just for physical sizes and the ease of reinstalling it. But you can't replace this one of the capacitors that has a larger VAC rating with one that has a smaller.